I'm Alex, and I'm a software engineer with the AWS SDK for Ruby team. So my team and I, we work on open source SDKs and toolkits for Java, .NET, Ruby, JavaScript, Python, PHP, Go, C++, the AWS CLI, the Windows PowerShell toolkit, and a number of IDE toolkits. So we definitely are making efforts to meet you where you are, and that's what it does. Today we're going to be focusing a bit on Ruby, but there's also a lot of general knowledge about how you can apply some DevOps techniques and app development techniques using our tools to your applications. So that's what we're going to cover today. All right, so to start off with, I just wanted to give a little bit of a retrospective on what we've been doing in the Ruby team through the course of 2017. So we released our third major version of the AWS SDK for Ruby, version 3. It is code compatible with version 2. So if you're already using version 2, it should be an easy migration. And of course, if it's not, treat it like a bug and file an issue against us. We'd love to hear about it. But it provides modular clients. So I don't know if we're past the 110 service count. I'm sure by the end of this conference we're going to be if we're not already. But it provides modular clients. So instead of depending on every service client, whether or not you use it, you can pick and choose just the services that you care about to depend on, which also lets you version the different service clients independently, which I know a lot of you have been asking for. It provides statically generated code, so it's going to load faster. And when errors do come up, the stack traces are going to be much, much easier to follow in version 3. And it also provides concurrency improvements. So many of you might know that the Ruby standard library autoload method is not thread safe. And those of you who've been using the Ruby SDK in threaded applications in version 2 have had to have some workarounds to get around that. Version 3 fixes that. We don't use autoload anymore, except for at the very highest service client level. Everything is eagerly required, and because we have statically generated code, you still get good performance at load time. Version 3 is also supported by the other AWS Ruby gems that we have available for you. So aws-record, a library that ties into DynamoDB, which we're going to be talking about today, as well as the AWS SDK Rails gem. And of course, if you want updates on what we're doing or if you want to reach out with feedback, you can find me and our team on Twitter at AWS for Ruby or Alex W. Wood. So check us out. All right, so let's talk a little bit about what we're going to be doing today. So we're going to build, almost from scratch, a Ruby on Rails API that runs on Amazon DynamoDB rather than a relational database using the AWS record library. We're going to define, using AWS CloudFormation, the infrastructure we need to run our application, as well as a code pipeline to manage and deploy it. Of course, we're going to walk through some of what you can do with code pipeline. And we're going to talk about our newest Ruby feature, which is generated API clients. So those of you who use API Gateway, you can now generate Ruby SDKs in the style of the Ruby SDK that you use automatically through API Gateway. And we're going to show, like, starting from building the service, defining its API, and then actually getting a client and running it, or even bootstrapping a client to run integration tests inside your pipeline. So it's kind of cool, and I think it's going to tie together really well. And all the code you need to check this out is available on GitHub right now. And I'll have the link up again at the end of the talk if you are kind of rushing to type that out. But it's on reInvent 2017 DEV207 code. And I've linked it out on Twitter. I'll leave it up again at the end of the talk so you can track it down. But the code that we're running through is all available on GitHub if you want to play around with it. Yeah, so to get a little bit more detail about what we're doing. So again, our Rails API, the backend is DynamoDB, and we're fronting it with API Gateway. So we're kind of going on both sides. What you might know about API Gateway is that you can have different targets for what your different operations are running against. It can run against a Lambda function, but it can also run against API endpoints, such as a Rails application, and that's what we're going to do today. We're going to use, within AWS Code Pipeline, the ability to run unit tests within code build as a first sanity check stage of any new deployment. And we're going to talk about how you can use AWS Code Deploy, both with tagged instances for testing or auto-scaling groups in production. We're also going to show you through a CloudFormation template how you can define your instance configuration, your IAM roles to handle credentials within your application, and tagging to tie it in together with all the rest of the infrastructure that we're building. So to start off with, we're going to build an example API, and we're going to do that using AWS Record. So what is AWS Record? Quick show of hands, who's tried this out so far? Okay, you've got a few hands. So I think it's something that's pretty easy to use, so I'd encourage a lot of you to play around with it and see if you find it useful. But we're going to hopefully show how you can easily integrate it into a Rails application today. So AWS Record is designed from the ground up around Amazon DynamoDB. So a lot of you said when we talked before the talk started that you use the Ruby SDK for application development. So you're probably familiar with libraries like Active Record. AWS Record gives you a very similar, although not exactly the same, API interface. Because, of course, DynamoDB is a NoSQL database, some of the Active Record concepts around relations don't apply in the same way, so we don't include them. And DynamoDB itself gives you interesting types that relational databases don't, such as collection types, map types even. And AWS Record has built-in support for that. Of course, DynamoDB being a fast and scalable NoSQL database that gives you consistent latency no matter what scale you're at can be very useful for these types of APIs that we're developing, where you want to be able to scale up with your user base, and we have basic CRUD operations. So it's definitely a very useful alternative for a lot of your Rails applications, either as a wholesale replacement for the databases you're using now, or for some of the use cases that you have, such as like user sessions, authentication, and that kind of thing. And the AWS Record library doesn't force you to choose. You can mix and match. You can use it exclusively, or you can use it only for testing, for example. You can find it on Ruby gems at AWS Record. Major version 1 of AWS Record depends on version 2 of the Ruby SDK. We also have major version 2 of AWS Record, which again, same code interface, except it depends only on the AWS SDK DynamoDB gem, which is part of the modular clients that we're offering in version 3 of the SDK for Ruby. It also provides helpers for table configuration, so migrations would work a little bit differently in DynamoDB than it would in a relational database, and so we're also going to explore a bit about how you can configure and manage your tables from within your Rails application. So to start off with, I wanted to do a quick demo of how AWS Record works. So just because I don't trust conference Wi-Fi, some of these are going to be recorded demos, and some of them we're going to do it live. This is going to be a coded one, recorded one. So again, very similarly to how you might use Active Record, you can define your objects. We have similar constructors, and you can see that it's got a lot of the dirty tracking underneath the covers. In this case, we have a type that has some timestamps, so we can define that and switch it to UTC because we don't want to have a real big problem with customers across regions. And it's easy to update your item attributes. Of course, if you have things like pry, you're going to get tab completion, even though we're dynamically generating the methods that you can use for getters and setters in your models. And we can tie in, but you don't have to tie in with active model validation. So in this case, I had a little intentional failure where I didn't define the object body and it refused to save. Until I update it, you can see the error message at the bottom, like you would have for any Active Record object you make. So once you define a body, your validations can pass. And in a similar fashion to how Active Record works, you're able to save your object change. And you can also update items. So DynamoDB gives you the ability to do upserts. So for example, if you're using concepts like single table inheritance, where you might have the same key set but totally different attributes in the same table, you're not going to be smashing the attributes that this doesn't know about, because it's going to be sticking to updates, which is very handy if you don't want to have a race condition where your items are getting smashed by whichever part of your application touched it last. So provides dirty tracking, and we also have slightly more complicated dirty tracking than active record because Ruby arrays and hashes are obviously mutable. So the dirty tracking of is the object different would simply say, nope, it's not, nothing to change. So we actually keep deep copies and check against those to make sure that we're properly tracking changes to mutable types. And if you need better performance, you can turn that off in configuration. But again, as you can see, the API is very similar to what you would find in active record. So the hope is that it's an easy transition if you want to start using this and developing applications without having to learn a totally new way of managing your applications. As a handy thing too, if you use methods like scan and query, we give you lazy enumerators that aren't going to fetch your whole table right away. It's only going to grab it one page at a time based on what you're requesting. So that can be a handy way to say, I want to scan and grab the first 20 items, but I don't want to look at my whole million item table to do it. This is going to be smart about what calls it makes. So that's a little bit about AWS Record itself. And what I want to talk about now is how we're actually going to integrate it with our application. So we have a Rails application right now, let's say. Very similar to what you would have if you're just generating a default application. So the question then becomes, how do I actually get AWS Record working? So let's walk through it using the open source repo that I linked before, and we'll link at the end of the talk. Okay, so first up, simple enough, is to include the gem. And I'll just go ahead and say that while we're doing the live coding parts, if anything is confusing or if you have any questions, feel free to raise your hand and let me know, and I'm happy to walk through what we're doing. So simple enough, add it to your gem file. And then one pattern you can use is rake tasks to handle your migrations. So one thing to remember is if you're adding non-key types to your DynamoDB table, there really isn't anything for it to do. It's only going to care about if you're adding key types, index types, or you're changing things like capacity. So we designed our table configuration and migrations to reflect that. So if I were to take a simple model and talk about how we would do migrations for it, we would implement it like this. So one thing is we can check what environment we're migrating from to have different behavior inside our table configuration. This is definitely a valid option. And we give you a handy DSL to help do that. So in production, and really for both, we're going to use the item model class that we're going to walk through defining later. And we need to define our read and write capacity. And then we're going to do similar for test and development databases, except maybe we'll have a capacity of 1, so that we're saving a little bit of money when we don't need to actually scale up for users. And then once we've defined that, it's as simple as running a configuration migrate for whatever you defined. So the nice thing about it is, if you call the migration method, if the remote table already matches, it's not going to do anything. If the remote table is a superset, so it defines, say, global secondary indexes that your model doesn't know about because you're using single table inheritance, it's not going to touch it. If it's a superset, it's going to say that's fine too. We also have a method for migrating to exactly what you define. So if you actually do intentionally want to overwrite any additional configuration, you have the option to do that. But by default, a migration is just going to make sure that what's remote is at least a superset of what you've defined. And that's all you really have to do to get table configuration working against your database. Okay, so what is the application we're going to build? It's a Rails 5 API, so we're not going to have views. We're just going to be returning JSON, and that's going to tie into our SDK development later. And to keep it easy to follow, so that we can focus on the AWS integrations more than the app itself, just 5 CRUD methods. Creating an item, getting an item that you've created, updating an item, deleting an item, and listing items with pagination. So the pagination one gets a little bit more interesting, but it's actually pretty easy to do with DynamoDB. So with that, let's actually code what this is going to look like. Okay, so we have a little bit of a shell of a model class right now. You'll notice that we're requiring the AWS record library, but other than that, we haven't defined a whole lot. So again, what I'm trying to show is that this is pretty easy to do. So we just need to include AWS record. And then we can also include active model validations. So AWS record itself only depends on the AWS SDK and the standard library. We're not bringing in a large number of dependencies. So if you'd like to use something like active model validations, we have hooks that tie in with it, but it's purely optional. So if for your application that's going to bring in way too many dependencies, or you prefer a different validation library, that's totally fine. You can use that. One difference, though, and this is similar to data mapping libraries, is you actually have to define your types inside your model. And this is simply because for any non-key applications, we have to give it a hint, or any non-key attributes, we have to give it a hint as to what the types are and what the naming is that we're expecting on the remote end. And we have documentation with examples inside the Ruby dev documentation. So if you want to try this out, there's a lot of examples you can follow. And because we have active model validations, and to kind of go back to our earlier example, we can mark all of these as required. Okay, and then if we're following the principle of trying to keep as much logic as possible out of your controllers and in your models, we can provide some helper methods that are going to be useful to the controller methods we're going to write later. So creating an item is relatively simple. Since we're decorating an AWS record, we can just say create a new item right here. So we're doing a model level method rather than a class instance level method. We don't want users to define their own UUIDs, so we'll bring it for them. We take the body they provide, the current time, and we use that same time for both the create and updated date. And we give that item back for the controller to save. So pretty similar to what you'd already be doing with active record. And similarly for update items, this item is already going to be hydrated with whatever was at the remote end. So we just need to take whatever attributes we're allowing the user to change, maybe updating the updated date itself, and then that's it. I'm not going to live code the list logic with pagination since it's a little bit more complicated to follow, but essentially we can take user-defined limits, which is similar to what you'd probably be experiencing if you're using the AWS SDK itself with paginated APIs that we have. We can use that lazy scan method, and if you were writing a query method, you could do much the same with a lazy query enumerator, and get things one page at a time, return that page of values to the user, and give them a key that they can use for making a subsequent call, and then that way you're going to start with DynamoDB at that next page. So, I mean, how many of you have written paginated APIs using relational databases? Leave your hand up if it's fun. Right. So hopefully this is a little bit of an easier experience since pagination is built into the DynamoDB API. It's a lot easier to interface with. And just for people watching on video, not very many hands stayed up for people finding pagination fun, but honestly, more power to you if you find it fun. I'm jealous. All right, so that's all we need for a model. Now let's take a look at an item controller. So, oh no, everything's empty. How long is it possibly going to take to fill this all out? So again, because we've defined things in the model, this is going to be pretty close to what Rails scaffolding would look like. In fact, if you use AWS Record and you would really like to see built-in scaffolding, find me later and tell me how much you want that. And we'll see how we're prioritizing that, because I want to know how many people would be using that. All right, so we're just defining the inputs. So for list items, we'd want to get our next token if the user is providing one. And similarly for limits, and it wouldn't be a live demo if I'm not typoing some things from time to time. And we'll just make sure that that's an integer. And because we're not using views, because it's a JSON API, it's just as simple as JSON rendering the response we're getting back from DynamoDB through API Gateway. So pretty simple to deal with. For getting an item, this is kind of going to be mostly magic because setItem does all the work, but we'll define that later. Done, easy. Creating an item. Much similar, we're using the helper method that we've already made from the input we're getting from the remote end using the safe parameter validations that Rails provides. And if we're able to save it, then we're going to render the same thing, the hash representation of our item. And if we're not able to save it, we can render an error to the user, perhaps using the active model validation errors that we got. Update item is going to be really similar. So I'm actually going to copy most of what I've already done here. And because we've decorated our record class with update item, the controller is doing almost nothing. And then destroying it, again, is just the built-in active record-like methods. We can delete the item. All right, and then set item, which is used for all the getters, deleters, and updaters. We can again just use the find method, which is a little bit different than active records in the sense that we're going to have you name the actual attributes that you're using as keys, and also using a little bit of the Ruby 2 magic. although you can use this with Ruby 1.9 since we're accepting an options hash, but you probably shouldn't be using Ruby 1.9 anymore. But we do support it. We try with all our SDKs to keep as much backwards compatibility as we can with older versions of Ruby. We're not going to make that our call. So if you can get the item, you return it. Otherwise, we can render a useful error to the user. And we can provide it some helpers to try to make it more useful for people developing SDKs. And that's basically all there is. So that's all we have to do to integrate AWS Record completely with a new application if it's a simple CRUD API. The models are similar, and the controllers are almost exactly the same as existing scaffolding, other than the fact that we're just tying into the model helpers we made. Okay, so now we have an application. The next thing I want to talk about is how can we build an infrastructure around it? So there's a lot of ways to do this, but today we're going to talk about AWS CloudFormation. So for those of you not familiar, CloudFormation helps you define the AWS resources that you need for your application. So for our API, we would need an Amazon EC2 instance. Since we're going to be using code pipelines, we're going to make sure that instance is tagged for AWS code deploy. We're going to configure its security groups. We're going to provide identity and access management roles and instance profiles. So you'll notice when we defined our AWS Record integrations, did anyone see anything about credentials? There's nothing there. Because with the default credential provider chain in the SDK, if you have an IAM role on your instance, if you don't define any other credentials, we'll find it, pick it up, and use it. So if you're using EC2 instance roles, it's very easy to tie that in to your SDK credentials. And of course, we're going to make sure that these roles have the ability to let AWS code deploy run on the instance, and we're going to give it permissions to DynamoDB. Otherwise, this API is not going to work very well at all. We're also going to define our AWS code pipeline in different stages. One thing that's going to be nice is we're going to try to tie this all together at the end by auto-generating an SDK for our API and running it for integration tests. And we're not defining the Amazon DynamoDB table in CloudFormation, and we're going to let our Rails applications table config do that instead so that all that configuration stays in your code. But you could do it either way. All right, so let's walk through what this template is going to look like. And again, since there's a lot here, this is going to be available on the GitHub repo itself, so you can take a look at it with a bit more time, but we're just going to go through some of the highlights. So it's not actually that big. You tie in the VPC and subnets you need, but we're defining a role, we're defining a profile, basic security groups. In production, you probably don't want to give the world SSH, but I don't know what port you're going to be running from. We're going to define the instance itself for testing, a load balancer in production, an auto-scaling launch configuration for production, auto-scaling groups for production, and the different artifacts like a code commit repository, an S3 bucket, assume role policies, everything that we need to actually have a functioning code pipeline. And you can take this with some small changes and use this for your application as well. It's kept as general as possible. So including test and deploy steps, as well as code build for unit testing, test applications and groups. So, okay, that's a lot to follow. Let's look at a few snippets. So the pipeline itself is a bit long, but essentially what it does is it just ties into the different stages that you're creating. In this case, source, unit testing, test environment like a Gamma environment, and production. So a fairly short pipeline. And again, in case I'm going a little bit quickly, this is all on the repo, so you can pick through it at your leisure. And if you have any questions about how any of this works, feel free to let me know.
Yeah, where do you recommend storing that CloudFormation file?
So the question is where you recommend storing the CloudFormation file. If you're using it with parameters, you can store it in source code. You can store it in a bucket. There's a lot of answers to that question. It depends a little bit also on how complex your application is, like what is going to be covered inside your CloudFormation template. I'd be very interested to hear from people in the dev lounge, like what you're doing with your CloudFormation templates now and how that's painful or working well for you, because we'd like to explore that. So as far as a role goes, it's pretty simple. We're using managed policy ARNs in this case, which is the quickest way to get running, but you can actually define very fine-grained permissions that give you access to only the resources you need if you wish. But you can see here that this is actually not that hard to do. And it gives you a lot of security because if somehow someone is able to break into your instance, like you're leaving ports open, you have insecurities in an application that comes up, they're not going to be able to spin up EC2 instances and start Bitcoin mining. They don't have the permissions to do it. So it helps maintain the best practice of using only the permissions that your application needs to try to have security in depth. And then the EC2 instance itself is actually not that complicated for a test instance. We just have a single micro instance for testing running in a single subnet. And the user data is basically a base64 encoded way of saying, please install and run the code deploy agent on my instance. So anything that you need to get your instance set up, you can put that in the user data. And if we want to actually see this running, so I've actually created this stack. And you can see that it creates a fair number of resources. So there's a lot going on that we've made from this CloudFormation stack. And the nice thing is, if you're a developer and you have an application that uses CloudFormation, you can spin up the actual stack you're going to use and test against it if you're writing new features. So it can be very handy for something like that. And question over here?
Where in the CloudFormation does it do the bundle install? Does it make sure that the right version of Ruby is running RVM, anything like that?
Sure. So he asked, where in the CloudFormation does it do the bundle installation? And the answer is, it doesn't do it in CloudFormation. It's going to do it in our code deploy configuration, and we're going to cover that in the next section. But it's a good question. All right, so and one question that I get fairly often and that I wanted to cover really quick is, there's a lot of deployment and management services. There's a lot of integration services offered by AWS. Which one should I use? Which one is the right one? And there really are no wrong answers. I've given a talk similar to this before using OpsWorks. It's built on Ruby. That's a great option. Using AWS Code Pipeline with code build and code deploy, it's also a great option. Using CloudFormation works. Elastic Beanstalk works. Ways you can decide if you've made prior infrastructure decisions. So if you use Docker heavily, maybe you want to use ECS for your compute instances. If you're a user of Chef, that probably answers your question for you as well. So this is one way to do it. It's not the only way to do it. But if you're not sure what to do, this is a pretty good place to start. All right, so let's talk about those code pipeline deployments. So for those of you not familiar, AWS Code Pipeline is a continuous delivery service, and we're building something pretty similar to this here, although we don't have an explicit staging step. But it gives you automated workflows. So basically, as soon as you push your changes up to the right branch, it's going to start running your tests and send it straight to production if it's ready to go. Because these actions are automated, it's less effort. You're not having to think about it. Every change you deploy is going to run through the same tests. So when we have our bootstrap client test, if you have a sufficient integration tests for what you expect users to do and you accidentally slip a breaking change into your API, Well, that client's going to be different, your integration test is not going to work, and that change is not going to ship. So you're going to protect yourself from making changes like that, even if you didn't realize you had made that mistake. And because it's going to encourage you to use many small releases, this is going to have a lot less risk. I mean, I think I've been developing professionally for about 7 years, and I remember the era of monthly releases, and I remember when that switched over to daily releases, and boy, did my life get easier. I'm sure some of you can relate. All right, so as far as how we're using Code Pipeline in our own application, it's going to give us continuous delivery of our API. You can source from code commit or GitHub. We're going to use code commit as our please start deploying this to production signal. You can use code deploy to update your server instances. So we've talked a bit about this, and we're going to dive into the configuration here shortly. And because it has custom commands, that's where we're going to run our bundle installs and get our AWS record hooks. So let's go through a walkthrough of that. So here's our pipeline. Again, starting with code commit, running code build tests. It's the same thing we defined in CloudFormation. And we also have our integration test, and that's a bit cool, and we're going to get to that at the end. But when it comes to the pipeline integrations, so if we look at our application, there's 2 files in here that stand out. There's a build spec, which is what code build is going to run to do unit tests. So that's going to do a bundle install. It's going to do a record migration and test. And it's just going to run whatever unit tests you've defined. And that's all that stage does. When it comes time to actually run deployments, it's going to use the app spec, and that's going to say, take my source file, copy everything over to where it needs to go, and then run an install dependencies script. And that script itself is where we're installing our VM, installing the version of Ruby we need, running our bundle installs, running our record migrations, setting the region that we're running in case you run in multiple regions. You can define that through, say, environment variables and skip this. So a few ways to get there, and then starting up our application. So within code deploy, it's going to run an arbitrary script that does whatever we need to do to set up and get running. All right, so again, this is what we built so far. We have our CloudFormation template to spin up copies of our entire application from pipeline to app servers. We have the pipeline itself, and we have a Rails API running on DynamoDB, and we're going to talk a little bit about the API gateway fronting as well in the next section, but we have a working application at this point. So now I want to talk a little bit about generated clients. But first, I want to get a little bit emotional about SDK design. So I talked a little bit about our team. We support a wide variety of SDKs and tools for over 100 services, and every time I use a number, the number is too low. The number is always out of date. We're launching new services and new features on almost a daily basis across a bunch of different languages and toolkits. If we were hand coding this, that's not sustainable, it's not scalable, it would be all we ever do. I mean, it's entirely possible that a release has happened right now and I don't even know about it. Check Twitter and you can tell me. But if you're using automated generation, not only are you going to have fewer bugs, because once you test your generation, you know that you're going to be building your services correctly. You're not going to have transcription mistakes where, oops, I typed that parameter wrong, everyone's broken now. And you can actually scale. So if you're supporting over 100 services and you're getting feature launches every day, and your SDK generation is automated, that's going to be way easier to deal with. So that's what we've done in the Ruby SDK and the other SDKs. And now what we can do is bring that to you. So through Amazon API Gateway, not only can you front your Rails API or any other application that you want, you actually can generate Ruby SDKs now automatically from the definition of your API. So really quickly, just wanted to walk through the API Gateway integrations that we have. So there is a Swagger model in the repository, but just to give a quick summary, for those of you familiar with Swagger, you can define operations, like our create item operation. takes an item input that has the parameters we'd accept from a user, and it's going to return an item structure. And so that's how we're actually going to have an SDK that gives you actual static types for the API we just defined. And you can see an item structure here. It's relatively simple to follow. It has our 4 properties. It defines the types that they are in API gateways. So if you have SDKs in not only Ruby, but if you want to make SDKs in Java, JavaScript, Android, iOS, you can do that. It's all going to have the same experience, and it can be automatically generated. And if we go to API Gateway, you can see now that it's as simple as running a console command or an API command. You can get a Ruby SDK on demand. So again, we've talked about that. So now you can generate Ruby clients, but here's what's a little bit cool. I want to get into a little bit of a walkthrough of what you can do with these clients. All right, so I've loaded up an SDK client for the API that we just made. So if I want to do paginated list items, first I should probably require a client. Cool. That's easy to reason about. I'm not having to worry about as a customer, what is the wire protocol? How do I marshal my parameters? How do I unmarshal the response? It's just code. It's just another object I'm interacting with. So if I want to create an item, oh, I don't know what I'm doing. Oh, look, it's going to tell you what parameters are required. So it's going to bring that for you automatically if you define that in your API. Cool, so that works. I can take the ID from that response with helpful autocompletion, and I can get that item. Same item, I can update it. And again, because we've modeled this, we're telling the user which types of parameters we're going to accept. And it's going to give them validations if they make a mistake. Doesn't know what that is, it's not going to send it over the wire. And we can delete that. We can also, and this is a little bit fun, we can build in some pagination to our method here. So it's only going to give me the number that I asked for. And then I can start going over pages using the previous responses. Until there's no items left. So the built-in pagination is helpful. So if a user really wants to scan over everything and you're going to let them do that with the rate limits you provide, they can do that. Or if they only need the first few, you're not going to be slamming your database every time they want to list things. So that's a little bit about what the client looks like. But here's the fun part. I have a little integration test that I wrote. It's very simple, and it runs in a code build stage against our test environment. And what this does is it's going to dynamically generate a new SDK. So how's it going to do that? Well, every time it runs, it's going to call out to API Gateway and say, generate me a new SDK. And then it's going to put that in a zip file, it's going to open it up, and it's going to install it. And then, and you can do something much more sophisticated than this, it's going to pretend that it's a user. And it's going to start making some of these same calls. It's going to make sure that they don't error out. You can add any kind of validation to the responses you want. So you can pretend that you're a user. Which means that if you make a mistake, like the server is valid, but it's a breaking change, and it would break a customer, you can find that out before you ever hit production. And you can bootstrap every language if you want as well. So it gives you a lot of flexibility, and you can build this directly into your code pipeline. This is a very simple code build configuration. All it does is just says, run that script. Easy. So that's some of the power of what you can do with these auto-generated clients. And hopefully that this is something you find useful, especially if you're using microservices or a service-oriented architecture. And there's a question over here.
How do you deal with the authentication for the customers as well? Are you using any of the AWS services for that, or this just doesn't happen?
Sure. So the question is, how do you deal with authentication, I'm assuming like in these generated clients? So there's a few ways you can do it. And we give you all of the options API Gateway does. You can leave it unauthenticated and open. You can use custom authenticators. So API Gateway has support for this, and we have a authorization plugin in the Ruby SDK. So you can define what that authorization logic is and tie into it. Or if your API uses identity and access management permissions, they can define that when creating a client the same way you would using the AWS SDK, and it'll run those same authentications just like the AWS SDK would. So it gives you a few options. All right, so let's tie it together. So what did we actually build today? Question right here.
Yeah, sorry. So
No worries.
is there a way to inject model logic like you would do with an active resource if you're generating your SDKs this way?
To inject model logic, what do you mean?
If there was other custom codes, like we have some APIs we publish, we use active resources to subscribe them from the wrap, so we get a lot of model logic in there. Is there any place within this that you can add that?
So the question is if there's ways to add custom logic into the SDK generation. It's not something that we have currently, but of course, you can download the SDK, make any customizations you want before passing it on to customers, but come down to the Dev Lounge. I'd be interested to hear about what you're trying to do, and we can kind of pass that along. Yeah, so again, so what we built is a Rails API using AWS Record. We've generated clients automatically from that, and we've built an infrastructure around it. So hopefully this is something you find useful. Again, I'm going to leave this code slide up while we do the Q&A. But follow us on Twitter if you want to ask more questions or know more about what we're doing. And hope that you find this useful. Thank you. So we do have a microphone over here if people want to line up and ask questions, but I'll take some questions from this side as well and just repeat them, so I'll maybe go one and one. But question over here.
Can you talk about using Docker, if you've got any examples out there that might, instead of the CloudFormation parts, because it seems to me that I would wonder about the speed and including up a new image every time, installing RVM, running bundles where it doesn't.
Sure. So the question was about using Docker, and I think there are examples out there about how you can tie in Docker with CloudFormation, or you can just use that directly. You don't have to do it this way, as we talked about before. But it's definitely an option. And one thing too, another way to speed it up would be to bake your own image instance instead of using user data. This is just one way to do it that ties in well with pipelines. How long does this take to spin up? I think this example is about 5 minutes on medium instances for any new change, although I think it gets much quicker after the initial installation because a bundle install on an existing instance is not going to have to start from scratch every time, so it goes down to less than a minute. But this is also a small application, so it depends. And question from the mic.
Yes, I'm a heavy V3 user, so thank you for all the work on that.
Thank you.
Can you give a little background on how you came up with the shapes JSON files that are auto-generated, the history behind that, because it's pretty cool. And also, any thoughts on a new API interface like GraphQL in the future? Do you know if anything's coming down the road? Because a lot of the APIs for different services are just really convoluted.
So for for API Gateway or just for services?
Just in general, just like all the services have their own APIs and they
Sure.
do it all their own ways, and you want to get the databases, but then you have to make separate calls for tags and.
Sure. I'd love to hear in the Dev Lounge about some of these pain points specifically, so we can pass them on. But as far as the history of some of the JSON stuff, a lot of it was just trying to come up with how we could actually scale to the sheer amount of new features that AWS is launching without literally having that be all we do. So it also provides uniformity across SDKs. All the SDKs are going to do it the same way. Honestly, this is probably a topic that I need to do a whole talk on because there's a lot to it and it's very interesting. But yeah, thank you for that. Question over here.
Yeah, so we already have production code, and we're using like MySQL. How feasible is it to do a migration over to DynamoDB? And would you recommend it if you're talking hundreds of millions of records?
Sure. So the question was, if you're already running a large scale, like millions of records production application on a relational database like MySQL, can you migrate, and then would you recommend it? So as far as can you migrate, I would check out the database migration service. This is basically what that's built for. Some of the details are going to depend on like what does your model look like? How compatible is that going to be with DynamoDB? And as far as would I recommend it, it depends on usage patterns. It depends on your scale. So, what DynamoDB offers is definitely going to be consistency in your latency. It's going to give you that easy ability. If you get to a really high read rate scale, there's a lot that DynamoDB does really well. It's a hard question to answer in general, would I recommend it? But definitely at that scale, also like reach out to solutions architects. We definitely have people who specialize in that exact question. Cool. Any other question over here?
How well does AWS Record integrate with some of the other gems, like authorization or paper trail version monitoring, that sort of thing?
The question was, how well does AWS Record integrate with, I assume, other Rails gems that provide some advanced functionality? I haven't gotten feedback on that. So I would love to, if you try that and you run into any problems, I would love to hear about it as a feature request or as a bug report as appropriate. I know that we do have another gem that I didn't mention in the slide for using DynamoDB for user session authentication. That was a project we had in V1 that we actually ported over recently to the newer versions of the SDK based on customer feedback. So we've built some of that, but I would love to hear about these use cases and figure out how we can support them better. Absolutely. Question over here.
For the generated clients, first of all, that sounds awesome. Can you use that without API gateway, just off the Swagger files or something like that? Or
Sure.
does it have to be integrated with API gateway?
So the question was, can you do the generated clients without API gateway? So this feature in particular is tightly integrated with API gateway. I'd be interested to hear about what these use cases are for non-API gateway generated clients because it's a possible feature request.
Because, for our app right now, we have our server APIs, we have our web client, we have our Android client, we have our iOS client.
Sure.
That all have to make the same request to our backend API. If we could basically say, put it in Swagger files, generate the clients for all of them, say, here's the client, that would be amazing.
Yeah, if you time with API gateway, it's easy to do that now. For separate from API gateway, come find us in the Dev Lounge. I'd be interested to hear more. Question in the microphone.
Yeah, do you have any plans to support Ruby on the Lambda platform?
Do we have plans to support Ruby on Lambda? I will definitely take that feature request and pass it along. Tweet at me about it. I'm serious. All right. Any other questions? Yeah, question over here.
Yeah, one more. So does AWS Record, just give me 1 minute.
Sure. Does anyone else have a question while he's thinking? You got the floor.
Okay, so does AWS Record support cross-region sharding?
So the question was, does AWS Records support cross-region sharding? It can. So natively, what it's doing is it's saying, I have a table in a certain region. You can be clever about it. I'd be interested to talk with you about how we might configure that and if that user experience is smooth. It's not something that we've had a lot of feature requests for, but
Pretty much separate tables with some of the security regulations coming out from European
Yeah.
PLLs.
so if you have separate tables, and like they're defined as separate tables, you can make each table have a client in a different region. And you could have those tables have even the same definition. So there's ways you can do that now. If there's questions about like how smooth that experience is, that would be an interesting one to explore and talk about how we can do that even better.
And that fits in with the CloudFormation piece.
Well, with the CloudFormation piece, I mean, you can define, so AWS Record can hook in with existing tables. You don't have to create your tables through AWS Record. It's a convenience method. But, so you can define that in CloudFormation and just hook into it with AWS Record. Or you can, generate that with AWS Record. The thing to watch out for is if you're doing multi-region to make sure that you have access to those other regions so that your VPCs are set up the right way. But that's a solvable problem. Cool. One last question over here.
For the AWS record, we've been using that a bunch. One of the things I find that I tend to do with my classes is I tend to write a class method called where, and where I construct my queries and scans. Is there
Yep.
any plans on having more kind of that moving into AWS record itself? Things similar to where you automatically move the filters or the expressions, the key expressions.
Sure. So I think to paraphrase your question, and let me know if I'm paraphrasing it correctly, when is a higher level query interface coming in AWS Record? I would love to hear, and reach out to the issues because we've been asking about this. I would love to hear like how you're constructing these where clauses now. We'd love to get more customer feedback about how you actually want that to look so that we can build the right thing for you. So I definitely love to hear a lot about how you're doing that now. Great.
When you're saying, quick question, when you're saying
Sure.
the developer area, are you referring to in the expo hall?
I will check back with that on Twitter, but I believe that we're talking about the Dev Lounge in the Expo Hall, yes. All right, and then I think I got to get out of here. The clock is showing really low numbers, so thanks again, everyone, for coming and for the great questions. Thank you.